Good morning. Welcome back to the course. In this lecture, we'll take you to the lab for the laboratory demonstration. There's another tab here, that is advanced tab. Advanced tab is again used by manufacturers, like combine everything, combine type A and type A kinds of the materials here. Then the second tab is filament. After print, we have filament. Here we have the feeding speed, the filament diameter. The general diameter sizes which are available in the market are 1.75 mm and 2.85 mm. This filament that we have here, that we are using to fabricate and to demonstrate, is 1.75 mm. The flow is kept 100%. So, there is a particular property of the material, the filament, that is what is length of the filament, what is diameter, what is the flow, what is the temperature, equivalent temperature. All these properties are there for the specific material, for the specific kind of spool that we get from the market. So, those are sometimes given with the material then when we purchase. So, this is the filament. So, it is in the form of a wire. Again, the diameter is 1.75 mm, and when we see this flow is 100%. That means whatever input we give, whatever speed, feed input we give, it will run 100% in that speed only. So, whatever we are going to input, so it will work in that, according to that only. Now, next we can talk about temperature. To what temperature it will deposit at the bed? What would be the temperature of the bed? Print temperature is 230 degrees and bed temperature is 50 degrees. So, it is kept at least 50 degrees in general. 230 degrees is a temperature, we will discuss about this as well. This is one more thing that we mentioned earlier, there are two fans, fan 1 and fan 2 here. The two fans here, fan 1 and 2, after it fuses, it becomes viscous, and for the long time it will de-shape the CAD model if it is not properly controlled with respect to temperature. So, after depositing, these fans are responsible for the cooling and solidification of the layers. So, that is why it is mentioned in the software cooling. So, minimum fan speed, maximum fan speed, the two fan speeds here. Minimum fan speed is kept at 50%, maximum fan speed is kept at 100%, and minimum layer time is 5 seconds. It takes 5 seconds to cool the last layer of what was deposited earlier. So, in 5 seconds till it will take care of cooling, 5 seconds is the time set in that. This is called curing of the metal. This is called curing of the metal when we do cure. Okay, cura word is also derived from this curing. So, this cura, you know, we have now a broad understanding of the cura software. So, this is temperature curve. Temperature curve, we can see the temperature of the output of the bed. It is from 0 to 100. If we say the output is the output, it is coming actual temperature here, what is output coming, and the output of the extruder. Then it can just show the curves when we actually do machine, when the machine is running. This is 3D view, this is temperature curve, and this is cura. Now, this is in 3D view. We can zoom in and zoom out. This is zoom out, this is zoom in, this is moving up and down, zooming out, then isometric, then front view, isometric view, and other axonometric views that we can see here. This is top view, this is front view. Okay, this is now isometric view. So, we are still working in this tab slicer, we are still working in slicer only. So, as we discussed before, the slicer is the most important tab what I feel in this software when we need to decide. Most of the parameters are decided here only. So print preview is just a preview, and we can, the manual control is when we need to control the machine manually, when we do not trust the G code, or this is not a question of trust, it is about when we need to make some modifications according to our requirements, so as we can machine it in lesser time, or we can induce some new features than manual machining control. But whenever we do need to do something manual, then manual machining control can be done. So we have discussed object placement and slicer. So we have discussed, like, this is a copy command in object placement, mirror command, rotation command, all these commands whatever we have used for the proper alignment. Now in slicer we have a few things like adhesion type. What is adhesion type? Adhesion type here that is given is brim. Print configuration, this is a part of the kind of the machine model that is put here. The adhesion type is brim. What is adhesion type? Now here we provide a little bit more material. Here we use a little bit more area to deposit the first layer. For the very first layer, it will be bigger in size of from the CAD model whatever we have obtained, and what we are actually going to print, this layer, the first layer will be bigger. So but it has to be only first layer. Adhesion type is the first layer. First layer, whether it is brim or it is raft. We can, so after this first layer, the second layer would follow the CAD model. Okay. So we can have two major kinds of skirts along our model. Like this is the model, the skirts along this can be built. The skirt can be brim or raft. So this play very important role, because this layer will stick with the machine. It will stick with the machine, this tabletop. Okay, this hot plate will stick here. So if we do not provide any extra material to the periphery of the job may stick on the bed, and we may lose some features on the base of the job. So we can use this feature only when we find that more material has to be added, that this job is necessary. Okay, when more area is there. So if we say none, it wouldn't have any brim or raft, or it might decide brim. So if we are very much conversant that okay, this specific type of job would need a brim or raft, are both the kinds of skirts. So when should we use raft or when should we use a brim? What are advantages that they have with each other? That in that we can say a raft would allow for better adhesion for the whole print, as raft attaches to the printing surface and the print attaches to the raft. Like if this is a print and this is the print that I need to produce, I need to produce this model. If there is first layer that is throughout this throughout the base, okay, at the whole base, that is raft, brim would only on the outer periphery. Okay, so this brim and raft can vary. We can see that whether raft is required or brim is required depending upon the material that we are producing. So brim does not help a lot with layer adhesion, as it is only one layer. Raft can even be more than one layers, because normally when we use raft, it needs a light looking the first layer, like in general, like we are talking about the first layer already, adhesion type, but raft can be even more than one layer. Brim is only one layer always. Rafts are primarily used with ABS material to help with warping and bed adhesion. They can also be used to help stabilize models with small footprints or to create a strong foundation on which to build the upper layers of your part. The raft, a lot of work is being carried out, a lot of research is carried out in raft and brim design, like to decide how many number of layers, and optimization is happening in this. So 100 of different machines are produced to minimize, because raft or brim, whatever we have, raft and brim would be an extra material that is wasted at the end. So this wastage has to be minimum, but the quality of the product shouldn't be compromised. So we can decide between these two. Okay, about brim. What is brim? Brim, as I said, it is just at the outskirts of the job. So brims are often used to hold down the edges of your part, which can prevent warping, and it also helps in adhesion with the bed. It is actually known to the manufacturer that would the quality of the product vary with using brim or not. So in general, brim command is preferred into that, like to reduce the wastage of the material. So the second layer onwards would follow the CAD geometry. In this specific model, the brim and raft are only the first layer, as I mentioned before, but in certain machines raft can be more than one layers, as I mentioned. So we have just kept it as none, that is, we are not getting any brim or raft here. So whatever we do, whatever we dimensions we give, it will just start manufacturing the component without depositing any other layer here. Okay, so like you can also see, brim none disables this function. Brim adds a single layer high area around your object, which can easily be cut off afterwards. Brim is required if objects warp at the edges, if the edges are more important. If the edges are more important, like this edge, okay, this edges are more, brim is used. Raft adds, this is the help that is given by the software. Raft adds a thick raster below the object and a thin interface between this and the object, which can be removed after printing. This is required if you have a bumpy bed or such a small object that would not stick well during the print. So I think this makes it very clear. So normally we don't use this feature, brim or raft, we have just kept in here. We can use this feature only when we find that our job, whatever we are going to print, is perfectly flat at one end, that is rectangular, cuboidal, cubical, or at the cross section or at the bottom of the job. Then we can use this. We are going to demonstrate this, but we are going to clarify you that this one thing, this is brim. So this is brim that is taken off from the job, that is prefabricated. So this is the model that will be developed. So this is the pocket. This extra material is brim. This extra material is brim. Okay, this whole material is brim. So this is taken off from the project that was manufactured before. So this will stick with the bed properly, and this enlarged area, this is the first layer, this will provide a good holding with the bed. So we are talking about an selection brim here in the software. So when the nozzle head starts printing, it is the actual model that we want to print, but it will deposit a little extra material to produce this first layer. This is actually the brim. Okay, this is the model that we have. This is the model that is produced. So it will deposit the material, a little more material. So this material was produced in this way. This extra material is brim. Also we have more extra material here, those are supports that will just try to show you how when we remove them. We can remove brim by hand very easily, manually, and we can get the finished final product. If the CAD model is flat, it's okay. If it is not flat, if it had some inclination, as I said, what would happen? How would the machine take care of the printing? It would provide some support. Now the printing would take place. Now we can see this profile that is created here. It is a mesh. This is not a solid profile. This is just a mesh that is created because it has just deposited some material. Now this support, we are trying to remove this one. We are trying to remove this support. Yeah, this support can be removed by hand. So this is a support material. In this case, only one spool is used, and both the model and the support materials is spool. That is why the color is also, the color of the spool is obviously one that is yellow only. So it is done by a single spool here. So we can even have the support material, that is a little cheaper, because the support material is not the final function that we need to present, that we need to provide. So this is the potential or the beauty of FDM technology, that if there is any inclination or any pocket or any profile inside it, the machine will program on its own and deposit the material. Again, this is what we mentioned earlier, the quality, that is at what quality we want to print, that is 0.1 mm, 0.2 mm or 0.15 mm support type. Okay, again that selection is there. Now this is printed, this product is printed with the quality 0.2. So they are fine, they are a little lines. So these are fine lines, we can say fine lines. So fine and coarse are subjective terms, okay, but according to this machine these are coarse lines, 0.2 mm, okay. So if we make job with 0.1 mm, these lines would be a little finer, so the smoothness would be better, okay. So we can select, as we mentioned before, that 0.1, 0.15 and 0.2 mm quality. There are 2.2 mm per slice. What is the thickness of the slice that we are selecting? So again the term quality is here, like I said, quality 0.2, we need to select the quality according to the kind of the finish we require. And also, as I said, the quality and speed are countering each other. If the quality would be higher, the speed would be lesser, because 0.1 mm and 0.2 mm, obviously the speed would be 50% of 0.2 if I use 0.1, okay, because 50% of the layer, 50% size is being deposited at each layer, at each slide. The support type, as we said, we use the word support, that is if there is any inclination or any pocket or any profile, we need support. The support type we can again play in 3 modes: none, touching bed, or everywhere. Touching bed means it would just like to touch the bed. For instance, if this material is here and this is my bed, it would just like to touch the bed. For touching the bed, it would just provide support wherever it need to touch the bed, just touching bed. So if we need higher quality, we can even use this option everywhere. Otherwise, no support. Also, it is given none, disable support. Touching bed is the most common setting. It will only create support where the support structure will touch the bed. Everywhere it creates support, creates even on the top of the parts of the model. Even on the top, even if it is not touching the bed, it will create support. So if we know that our CAD model is good enough and is flat, we need not to have any support, we can choose none. So if we are not aware, or we do not have any information about that, whatever the CAD model would be from inside, or there are different intricate features. So in case of complicated, very highly complicated CAD models, if the face is, there is no flat shape or shape anywhere, then we need to set the command to send this command, this option to everywhere. So we are talking about the support type, and support type is set to everywhere. This is one of the jobs that is kind of complicated. So you can see there are multiple shapes here, okay. So in this CAD model, if you see, in this CAD model we use everywhere command, okay, because it is profiled everywhere, like just not touching the bed. For instance, this is the model, like I just said, it is touching the bed. If there is another model, for instance, another thing is manufactured here, this portion, the portion in between here is not touching the bed, but it will provide support here as well, because it has to produce this thing as well. So in case of touch bed, it will provide support here only. In case of everywhere, it will provide support here as well. So which is complicated, we use the option everywhere. Now the software is responsible to fill the support wherever it is needed. So it is the art and skill both. You know, in manufacturing, as we know, the CAD, the computer did design, the different softwares are there, but whatever the software, that is just software might be quite intelligent, but it is all designs come from here, it just comes from the designer. So there is always an art associated in designing, then besides the skill as well. So this is we are talking about the slicer, and we were talking about the support type. Then speed. Speed, as we discussed, the speed, print speed, as it is fixed to 40 millimeters per second, outer parameter speed is fixed to 20 millimeters per second, and in-field speed is again 40 millimeters per second. We can make it fast and slow using this tab as well. So again, print speed is 40 millimeters per second, outer parameter speed is 20 millimeters per second, in-field speed is 40 millimeters. So there is a checkbox here, enable cooling. So if we enable this checkbox, it activates cooling fan while printing. This can be significantly improve the print quality, especially for the PLA and bridging and overhangs. It is specifically mentioned for PLA. If we enable cooling, the fans would run when we print. So there are two nozzles here, okay, extruder nozzle, extruder 1 and extruder 2, okay, extruder 1 and extruder 2, two nozzles are there. So accordingly, we have two nozzles here, extruded 1 and extruded 2. We can put the material. What is the kind of material? We have put it ABS for extruder 1 and ABS for extruder 2. So we can just input the kind of the material that we actually have. So as we said, we can't manufacture multicolor jobs with this machine because we have only two nozzles, but yes, two colors can be produced. So we are just trying to tell you that how slicing would be taken care. So how do we do slicing? Slicing is just one click away. Now this big button here, slice with Cura engine, after making all the settings in slicer, this very big button, the slicing is just one click away. When we click this button, okay, slicing starts. Now the slicing starts. You can see that it has made a brim by itself, okay, as it might have found it important. The machine is quite intelligent to do this. The software is quite intelligent to decide this thing. So this brim is, you can see this skewer is there. Why this skewer is there? This skewer is for holding. We need to hold the job and take it off. Hold the brim layer and take it off. Okay, this skewer is for holding, and the other portion, this outer portion is the brim. Okay, because it has to, it would like to save the edges or make the edges proper. Okay, brim is only at the edges. Had been rough, it would be along all the surface, complete surface of the job. Okay, so this slicing. Now it is showing the properties. Now it is showing estimated printing time. Estimated printing time is 5 hours, 2 minutes, 33 seconds. So it is giving the data. This is print view. After slicer, it has went to the next tab here. That is print preview. Okay, in print preview, it is giving the information that this kind of this is the time that would be taken, 5 hours, 2 minutes, 33 seconds. Total layer counts would be 144. Total lines would be 145570. 1,45,000 lines would be drawn, and filament that would be needed would be, the length of the filament that would be needed would be 19,500 mm. So this information is displayed here. So in this print preview, once we click this button print, we can see how short travel moves, how the layers would move. Now these sky blue lines indicate that we will show that it will print the material in this way. We could go with the single layer also and show layer range. Okay, show layer range. Okay, this is the first layer. how it would print. Okay, it is showing travel moves here, showing travel moves, how it will travel. When we will actually do, we will also try to show you how it moves, and it is showing the layer range. Now we can just pan through the window. Okay, show complete code. Now there is a button here, or not button, there is a radio button here. Among these three we can select one, show complete code, show single layer, show layer range. So single layer we have just shown you, show layer range is also shown. Now show complete code. This is the complete code. Complete code would be like this. The material will come from this side. Okay, it will start machining, it will start producing. Actually machining, when I say machining, in general what we think of machining is subtraction. Here machining is addition, material addition happens from here. This is produced. Now let us click print. Before we actually do print, we have to also prepare the bed, prepare the machine, or all those things. The machine has to be set up properly before we actually start, because once we click this, it will start printing. Now we have made certain settings, we have made certain inputs here, and some settings are there, the CAD model, everything is there. We can save this to a file using this thing, save to file. Okay. Also, if we have deep information or deep knowledge about the G codes, about the CNC programming, we can add or subtract or edit the features using edit G code. X, Y, Z movements can be controlled using G code programming system. So this is G code editor. Okay, after print preview we also have the G code editor here. So we can change the CAD profile, that what we need to print without printing, without using the CAD model. Now the last tab is manual control. The main manual control, what happens, we can control the machine manually. You can see X, Y direction here, X and Y direction can be controlled manually, Z direction can be controlled manually, and also this extruder can be controlled manually. In manual control, it is very important that it starts from beginning. By doing manual control, it starts from beginning and it ends at finishing as well. So like movement of the nozzle, in manual control we can move the axis manually. Here we can play with the setting changings, and we can change the temperature as well here. So before printing we also need to set the temperature. This is known as soaking temperature. Okay, the nozzle temperature that was kept 230 degrees. So we have to activate. Now this controls the extruder temperature. Typically the temperature for PLA is from 180 to 220 degrees, and for ABS it is a little more than that. So we are using single extruder for both printing that is the actual model, and for support. So we are activating this. So this red cross means it is not activated. This red cross is taken off, means red line is taken off, that is it activated now. Extruded 1 extruder, it is now it has now started heating. When we have activated the temperature 200 degrees, it will now heat up to this temperature, 200 degree temperature. Actual temperature we can see here when it is heating, temperature curve here when we will open here. Okay. So bed temperature is also activated now. Bed is also heating, it has started heating. Okay. So the bed temperature again for PLA, the bed temperature is 55 degrees, and the fan is also switched on manually. Now there is another way. If we go to print button here, when we click print, all these manual controls that we have done manually, these will be activated or enabled automatically, because bed has to be heated, the nozzle has to be heated, fan has to be kept on. All the settings that we made before would be activated by just clicking of this button. So this is the automated mode. So the use of manual control is that we can display the temperature, we can alter here the temperatures, but in the automated control we can't alter once we fixed. So we can increase or decrease the temperature. See, we are increasing the temperature of the extruder. It was 200, we are increasing it to 230. Okay, here increase to 230. So sometimes we also play with the atmosphere temperature. In the summers, the temperature, room temperature is generally here in Kanpur is from 37 to 43 in average. Okay, so it is quite hot in extreme summers, and in winters it even comes down to 5 degrees or 6 degrees. So depending upon that, the temperature is also set. If the temperature, room temperature is lower, this temperature is also kept accordingly. It is winters here at this point of time when we did this demonstration, so the temperature is kept a little higher. So because the room temperature is quite low here, so the filament temperature is made a little higher. Otherwise it was to be kept 200 degrees here. We'll meet in the next lecture. We will discuss further about the course. Thank you.